Hey, what's up you guys? Thank you for joining me again. Now in this video, we're going to be working on the third subtopic of this chapter, which is area of polygons. So let us jump right in. So for this chapter, right, there are two main things that you have to know. Both are basically explaining the formula for area of polygon. So the first way you're going to calculate is, let's assume that you have a shape like this, okay, a random polygon. Okay, I'm just going to draw a random polygon. Okay, so basically you have A, B, C, D. Let's assume A is x1, y1, x2, y2 for B, x3, y3, okay, and then you have D is x4, y4. So how do you find the area of polygon? So the first method is like this. You're going to write 1 over 2 modulus, and then you're going to write down all of the coordinates. Okay, so let's say you put x1, y1 first, and then you put x2, y2, x3, y3, x4, y4. So you're going to put all of the coordinates of the vertices for this polygon, and then at the last part you have to repeat whatever you wrote at the first part here. Okay, so you're gonna, since I put x1, y1, so I'm gonna put here x1, y1. Okay, so this is the formula. Now how do you calculate this? It's like this. You're gonna rewrite 1 over 2 modulus, and you're gonna have two brackets. The first bracket is you're gonna calculate all the diagonals like this, multiply them. Okay, so when you multiply, you should get x1, y2 plus x2, y3 plus x3, y4 plus x4, y1. So this is the first part. You're going to count all of this, and then you're going to minus the opposite side diagonal. So you're going to multiply the opposite way. Okay, you're going to multiply the opposite way. So you should get another bracket here. You get x2, y1 plus x3, y2 plus x4, y3 plus x1, y4. Close modulus. Okay, so this is basically the formula to calculate area. Okay, now the reason why we use modulus is because whatever value you get here, it has to be a positive value. Okay, it has to be a positive. It cannot be a negative, because area will not have a negative. So make sure you get a positive value. Even if you get a negative value, the modulus will make the negative become positive. Okay, so this is one way, one of the formula. The second formula, which is optional, you can use this way, is this thing called box method. This is another way for you to find area of polygon. So let me just give you an example straight away. Let's say you have a polygon like this. Okay, you got a triangle, and let's say this point here is 5, 4. This point here is 8, 2. Okay, and then here is the origin, so it's 0, 0. Okay, now how do you find the area for this polygon? So to find that polygon, you are basically going to form your rectangle. You're going to form your rectangle. Okay, so you're going to find all of these areas, one here, and this second one is here, number 2, and number 3. Okay, so you got 3 areas here. So what you're going to do is you're going to take the area of the rectangle, the entire shape. Okay, the entire rectangle minus the area of triangles. So you got 1, 2, and 3. Okay, when you minus all 3 of that, you will get the area of the triangle that you're looking for. Okay, so how do we solve this? So since we already have the coordinates, let us solve them together. So you have here 8, and then this coordinate here would be 2, here should be 4, here should be 5. Okay, so let us find the total area. Total area is the area of the rectangle. So in this case, you're going to take the length times width. So that means 8 times 4, correct? So you should get here 8 times 4 minus, so now you have 3 triangles here. The first one is 1 over 2 times, what's the base? The base is 5, correct? Times height. Height is 4. Okay, so this first triangle here is the first triangle. Next, you're going to add the second triangle, which is 1 over 2 times the base now is what? The base now becomes 8 and the height becomes 2 plus 1 over 2 times the third one. The base should be 8 minus 5 is 3 and the height should be 2. 4 minus 2. Okay, so they are basically 3 separate triangles. So now you can solve them. 32 minus, here you get 2, so you should get 10 plus, you can cut here, you get 8 plus, cut here, you get 3. So you're basically having 32 minus 8, 11, 21. So your answer should be 11. 11 what? 11 unit square. Okay, so this is how you use box method. But most of the time, most people will be using the first formula. I'm just showing you just in case if you're comfortable with this method, you can use it. Okay, so let us go straight to the examples. Find the area of the triangles with the following vertices given. So they already gave you the 3 vertices. So we're going to use the formula straight away. Area is equals to 1 over 2. You have 5, 10, 2, 1, 8, 3. And now don't forget to repeat the first coordinate. So which is 5, 10. Okay, so we're going to do this 1 over 2. The first one you want to count is the diagonal downward, going downward. Okay, so you should get 5 plus 6 plus 80 minus, now you got opposite direction going up. Okay, multiply upward. So you should get 20 plus 8 plus 15. Okay, so 1 over 2, here you should get 91 minus 43. So 91 minus 43, you should get 48. So your answer is 24 unit square. Right? Vertices P and Q are 3, 4, 1, negative 2 respectively, and vertex X is on the x-axis. Find the coordinate of R such that area PQR is 10 unit. So now they give you all 3 coordinates except the R. R they only told you is on the x-axis. So if it's on the x-axis, we know that the y value is going to be equals to 0. Okay, but we don't know what's the x value. So R, we don't know what's the x value, but we know y value is equals to 0 because it's on the x-axis. So now this is a bit tricky. I need you to pay attention here because this is the reverse process of the area formula. So there's a bit of trickiness here which I need you all to focus. Okay, so now the area, they told you area PQR is equals to 10. So how do we find area? Area is 1 over 2, the formula. So I'm going to key in all the coordinates again. So 3, 4, 1, negative 2. The R one, you're just going to put in x, 0. And then repeat the first one, 3, 4. Equals to 10. Now you're going to do what we normally do, times downward. And after that, minus the multiplication going diagonally upward. Okay, so you should get 1 over 2 negative 6 plus 0 plus 4x minus 4 minus 2x plus 0. So you close your modulus equals to 10. So first thing I'm going to do is I'm going to shift the 1 over 2 to the opposite side. Okay, to the opposite side. So what should I get? I should get the modulus remains, and what is in the bracket becomes negative 6 plus 4x minus 4 plus 2x equals to 20. So now here is where the tricky part. When you shift modulus, you have probably already done this in the first chapter itself, function. When we shift modulus, what happens is it becomes a plus minus. So on the left hand side you will have negative 10 plus 6x, and then when you shift the modulus it becomes plus minus 20. So what does this mean? This means that you will have two values of x, two possible value. The first possible value is when the 20 is positive. So 10 plus 6x equals to 20. So 6x is equals to 30, x is equals to 5. So this is your first possibility. The second possibility is when 6x equals to negative 20, because you have plus minus, right? So the first option is positive 20, the second option would be negative 20. So 6x is equals to negative 20 plus 10, you get negative 10. X is equals to, now you get a fraction which is negative 5 over 3. Okay, so you got two possible values, but since they asked for the coordinates, so that means r can either be 5, 0 or negative 5 over 3, 0. So two answers here. Okay, that's how you solve this kind of question. Points E, F, G are collinear. Find the value of P. So now, whenever you see this thing called collinear, remember, collinear means what? It's basically a straight line, correct? Collinear means straight line. So when you have a straight line, how are you going to find the area? Because straight line got no area, right? So in other words, when you see this word collinear, you know that the area of the polygon, in this case is a EFG, since it's not a polygon because it's collinear, so it's equals to 0. Okay, the area is equals to 0. So we're going to do the same thing and make the equation become equal to 0. So 1 over 2 times EF is what? Negative 2, negative 1. F is 2P, then 5, and then repeat negative 2, negative 1 equals to 0. Okay, make sure you put equals to 0 because it's a straight line, so there is no area. So then 1 over 2 I'm going to bring to the opposite side, and here I'm going to multiply like how I usually do. Okay, diagonally downward minus the ones that you multiply upward. Okay, so you get negative 2p plus 10 minus 10 minus negative 2 plus 10p minus 10, and then you should get 0. Now you notice I removed the modulus. Why? Because even if I shift the modulus to the opposite side, 0 there is a neutral number. There is no positive 0, negative 0. So in other words, you just assume it's a positive number. That means 0. There is no positive, negative. Okay, so how are we going to solve this? Like how we normally do, correct? So negative 2p minus, here you should get negative 12 become positive 12 minus 10p equals to 0. So negative 12p equals to negative 12. So p is equals to 1. This is your answer. The vertices of a hexagon are, okay, they give you all the 6 vertices of the hexagon. Find the area. So it's basically the same thing, right? Just use the formula. Area of the hexagon is going to be 1 over 2. You're going to put in all the coordinates. So 0, negative 1, negative 3, negative 1, negative 4, 2, -26, 1, 5, 2, 1. Don't forget to repeat the first part. You should get same thing, multiply downward and then multiply upward, okay, diagonally upward. So you should get 0 minus 6 minus 24 minus 10 plus 1 minus 2 minus 3 plus 4 minus 4 plus 6 plus 10. The last one is 0, so I'm not going to include that. So 1 over 2, you should get here what? Negative 41 minus 19. So your answer is 1 over 2 times negative 60. So remember, when it's negative modulus, it becomes positive, correct? So in other words, it is actually 1 over 2. Why am I writing sideways? Sorry about that. I should be writing downward. So negative becomes positive. So answer is 30 unit square. Okay, this is how you solve any random polygon. Just make sure you use the formula accordingly. Right? In the diagram on the right, points A, B, C, D are vertices of a parallelogram. M is the intersection point of diagonal AC and BD. Find the coordinate of C and M. So in this case, C is a parallelogram. So the characteristic of parallelogram is the diagonal here, they are basically midpoints, correct? They are midpoint. The M point, point M here, is actually the midpoint between D and B, and it is also the midpoint between C and A. So to find M, we can actually find the midpoint. So question A, you want to find M, right? So you can find the midpoint between B and D. So in this case, you get 5 plus negative 1 over 2, and then 2 plus 6 over 2. So you should get 4 divided by 2, 2, 8 divided by 2, 4. So this is your coordinate of M. Next, you want to find coordinate of C. So it's also the midpoint. So in this case, let's just assume that this is XC and YC, okay? So to find the C value, okay, we are going to take negative 3 plus XC, okay, divided by 2 should be equal to the midpoint, which is the M here. So is equals to 2. And then the Y is what? 0 plus YC divided by 2 equals to 4. So negative 3 plus XC equals to 4. XC is equals to 7. In this case, YC is equals to 8. So the coordinate of C is what? 7, 8. So this is how you find your coordinate. Now, question B. Question B wants you to find the ratio of area of ABM. So ABM is here. The ratio of this area to the ratio of the entire parallelogram. So basically, you just have to use the formula. So let's find ABM first, okay? Triangle ABM. Okay, the area is equals to, sorry, 1 over 2, I missed out. 1 over 2, and then A is negative 3, 0, and then you have 5, 2. The M value is 2, 4, and then repeat the first one. It's negative 3, 0. So you get 1 over 2. Okay, I'm just going to go directly, okay? So negative 3 times 2 is negative 6 plus 20 plus 0. I'm not going to write there. Minus 0 plus 4 minus 12 equals to 1 over 2. Negative 6 plus 20, you should get 14, minus plus 4 minus 12, you should get minus 8. So minus 8 here becomes positive 8. Okay, so you get 22 divided by 1 divided by 2, you get 11 units square. Okay, so this is the area of ABM. Now you want to find area of ABCD. Okay, I don't have much space here. So area of ABCD is equals to 1 over 2. So what we have, A is negative 3, 0, then 5, 2. C value is 7, 8, negative 1, 6, and the last one is negative 3, 0. Okay, so you should get 1 over 2, negative 6 plus 40 plus 42 plus, okay, I'm going to write down here, plus, no, nothing there, 0. So close bracket, minus 0, I'm not going to write, 14 plus, minus 8, sorry, minus 18. Okay, wait, let me just write this here so that you don't get confused. Okay, so this is separate. My bad, I got no space here, bear with me. So I'm going to write down here so that all of us can see clearly. So negative 6 plus 40 plus 42, you should get 76, minus 14 minus 8 minus 18, you should get negative 12. So here become plus 12. So you should get 1 over 2, 88 here. Answer is 44 unit square. So since they asked for ratio of ABM to ratio of area of ABCD is equals to 11 to 44. So your answer is 1 to 4. Okay, sorry I had to cram here, but I don't have any more space, so just bear with me, okay? Alright, next. The straight line, they give you a straight line here, equation of straight line, intersects the straight line y equals to y equals to k, x-axis and y-axis at point PQR. Given area OPR is 12 units, find the smallest value of k. So in this case, they give you the equation of straight line, and this line intersects 3 points. The P point, point P, is when y equals to k, Q point is when it intersects the x-axis, and point R is when it intersects the y-axis. So in this case, you can actually use the equation to find the x and the y-axis, correct? So it's going to be y equals to negative 2x plus 8. Okay, I'm making it in the form of y equals to mx plus c. So from here, you know that y-intercept is equals to 8. And the x-intercept equals to what? To find x-intercept, y equals to 0. So 0 equals to negative 2x plus 8. 2x equals to 8. So x is equals to 4. So your x-intercept is equals to 4. So now you found your y-intercept and x-intercept. So let us just plot the graph, okay? So both are positive. So here is 4. This should be, the coordinate should be 4, 0. And then here is 8. So the coordinate here should be 0, 8. Okay. Then you can plot your straight line. So this should be your straight line. 4, 0 is point Q, right? And 0, 8 should be point R. Now, we got two of the intersection point, right? Except one more, which is P. We don't know where is P, we don't know where is y equals to k, we don't know where is this equation. So y equals to k can be anywhere. It can be here, 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 and anywhere. Okay, you can basically find it any point on this line. But the thing is, one thing we know about this is, since they tell you point P is where they intersect, correct? So in this case, you know point P is going to be, you don't know what's the x value, but you know the y value of point P is going to be k, because they say y equals to k. So if y equals to 1, let's say, so you know it's going to be, the line is going to be here. So when the line is going to be here, guess what? This is equals to k, right? So the y value of the intersection point for point P is going to be k, the y value. But the x value, we don't know. Okay, so with this info, now we can start to solve the question. So they're asking you to find the smallest value of k. So since they gave you the area, we're going to use the area. So area OPR equals to 12 units square. So the formula, we're going to use the formula starting with OPR, right? So O is the origin. So O is 0, 0. P is, where is P? XK. Okay, we don't know what's the value of both of them. And then R, what is R? R is 0, 8. And then repeat the front one, 0, 0. Equals to 12 units. So I'm going to shift 1 over 2 to the opposite side. So I should get 0 plus 8x plus 0 minus 0 plus 0 plus 0. So everything is 0 here. So good thing, it'll be easier to solve. So 1 over 2 bring to the opposite side, I should get 24. So 8x is equals to, remember, when you shift modulus, it has to be plus minus 24. So that means x can be equals to 24 divided by 8. Answer is 3. Or you get a negative value. X equals to negative 24 over 8. Answer is negative 3. So since this is x, now we have to find the value of y. How to find the value of y? Substitute back into the equation. So when y is equals to negative 2x plus 8, okay, let's say x is equals to 3, what's the y value? Y value equals to negative 2 times 3 plus 8. Negative 6 plus 8 equals to 2. What about if x is equals to negative 3? Then y value equals to negative 2 times negative 3 plus 8 equals to 6 plus 8, 15. Okay, so you got two value of y. Remember, y is equals to k, so that means k is equals to 2 or k is equals to 15. The smallest value of k would be 2. This would be smallest value, correct? Because it's obviously smaller than 15. So now they ask you question B. They ask you to find the coordinate of P, which you have already found because you know what's the x value, right? So P is equals to 3, 2. Oh yeah, apologies guys. This is not 15, yeah. This is should be 14. 6 plus 8 is 14. Sorry, I failed my maths. And sadly, I'm teaching maths now. Just kidding. So K is equals to 14. But the answer remains the same because 2 is significantly smaller than 14. So K is still equals to 2. And the smallest value is obviously that. And P would be equals to 3, 2. Right?